All right, let's take a look at Chapter 17, Multi-Causal Relationships and Multiple Regression. And let's introduce this with a little example here. What is the issue? Well, most business performance outcomes are driven by more than one factor. That is the issue. For example, demand for my product depends not only on the price that I charge, but the price that my competitor charges. You know that when you go shopping for gasoline. There are other economic conditions too, seasonal effects, and the growth trajectory of the business. We're going to look at some apartment buildings. The idea being that many things ramify. Love that word. Most business performance outcomes are driven by more than one factor. When there are several drivers of performance, price, simply plotting the business performance against each driver can easily give you a misleading impression of how these drivers affect performance. The basic problem is that when all the drivers can and do change simultaneously, it's difficult to isolate the effect of each one separately. That word, ramify. All right, we're going to take a look at some apartment buildings in Washington, D.C. We have data on the sale price of 150 apartments sold in Washington, D.C. a little while back. All right, here's the data. Now, the key features that we're going to look at here are the total area and the number of bedrooms. If you look at the data there, the first column, column A, is just the ID of the apartment, doesn't really mean anything. Then there's area in hundreds of square feet, and number of bedrooms, and the price. That valuation in column E is something we're going to look at in the future here, so you can ignore it for now. We'll just use columns B, C, and D. The first graph, sale price versus size, refers to the area. And if you plot sale price on the y-axis and area on the x-axis in hundreds of feet, you get the data plot there on the left. And then you draw a trend line through it and ask for the, give me the equation, the y equals mx plus b of that trend line. You get y is equal to 4.7602 plus 49,486. And when you put that into the numbers we have there, the price is measured in units of $1,000, area is in 100 square feet. So the trend line suggests that if you could get an extra 100 square feet, that would be worth $4,760. Notice that that's the number right here, and the y equals m. M is 4760. So that tells you that it's about $47.60 per square feet. Then if you graph the sales price versus the number of bedrooms on the x-axis, sales price on the y-axis, you get this trend line, and you ask for the equation of that trend line, and you get y is equal to 10.158x plus the y-intercept. That tells me that an extra bedroom is worth, on average, $10,158. This should be a left eyebrow moment. You should say, what? One of these numbers is, in a very important sense, just plain wrong. Can you guess which one it is? And that's what we're going to do here. We look at these and say, which one is accurate and which one is misleading? So if we look at the pivot table below, we're going to make a pivot table of the same data and categorize the 150 apartments by number of bedrooms and then the area in categories of 200 feet. So the area is over there on the left-hand side in categories of 200 feet. We grouped it by every 200 feet. And then 2, 3, 4, 5 are the number of bedrooms. And then we calculate the average value of the apartments that were in that area range and had that number of bedrooms. What do you see? Well, what if we go from, just take for example the area of 14 to 16. Goes up by $10,000 when you go from 2 to 3 bedrooms, but then it goes down by $6,000 when you go to 4 bedrooms. If we stay in the 16 to 18 range, we go from 128 to 132, up by 4,000, 10, and then we go down by 3 to go from 3 bedrooms to 4 bedrooms. So, is it really true that you get an extra $10,000 for an additional bedroom? I don't think so. So, we look at our data here and we say, okay, well, how could the trend line be off like that? How do we parse this out when things change at the same time? And that's what the focus of Chapter 17 is all about. If you want to understand how a set of business inputs affect performance, you cannot look at each one in isolation and assume that the others don't affect things. You need to look at them in combination, and that's what multiple regression is all about. It can deal with as many input variables as you like, and it is simple to understand. In addition, you end up with a simple formula for prediction and standard errors for all your conclusions. Yay! That's what we're going to be getting into in this chapter.